So another type of energy we really want to go in depth with is thermal energy. So again, we talked about in part 3 during the conservation of energy. We talked about thermal energy is heat energy. Although we'll talk about exactly what heat is today as well. Because a lot of people get heat and temperature confused. So thermal energy is the total kinetic and potential energy of particles, not of an object, but of the particles in the object. Okay, so very important. It's not the object itself, it's the particles that make up the object. It's the total kinetic and potential energy of particles in an object. It depends on two main things. It depends on three main things. It depends on the mass and the temperature. So those are the two most important ones, but it also depends on the phase, whether something's a solid, liquid, or a gas. So for example, well, let's look at some examples here. Then I'm going to go into, like, for example, what happens with different phases. So, essential question, which has more thermal energy? A 100 milliliter beaker of hot water or a 100 milliliter beaker of cold water? Now, something you don't have to know, but 1 milliliter of water is equal to 1 gram of water. 1 milliliter does not, I repeat, does not equal 1 gram, except in the case of water. So basically what I'm saying, when I say 100 milliliters of hot water and 100 milliliters of cold water, I'm saying 100 grams. So which has more thermal energy? Well, they both have the same mass. They both are liquid phases. The only difference is one is hot water, one is cold water. And duh, it makes sense that hot water would have more thermal energy than cold water. So yes, A, the hot water would have more thermal energy. What has more thermal energy? A beaker with a little bit of water or a beaker with a lot of water? Now we're going to assume that they are at the same temperature. So both are at the same temperature, both have the same temperature, both are liquids. Which has more thermal energy? Good. Hopefully you said the beaker with a lot of water, because again, thermal energy depends on mass. The more mass you have, the more thermal energy you have. I repeat, the more mass you have, the more thermal energy you have. The higher your temperature, the more thermal energy you have. Gases have more thermal energy than liquids. Liquids have more thermal energy than solids. Next one. Which has more thermal energy? An ice cube, which is 0 degrees Celsius, or a lit match, which let's just pretend is 100 degrees Celsius. It's actually way hotter, but let's just pretend it's 100 degrees Celsius. Which has more thermal energy? The answer is a little surprising. The answer is an ice cube. Even though the ice cube is so much colder than a match, here's how to know. Ask yourself the following question. Which would you run out of first? Would you lose the entire, would the whole ice cube melt before the match completely burns out? Or will the match completely burn out before the entire ice cube melts? Odds are, if you took a normal size ice cube and a normal size match, you're going to run out of match before the entire ice cube melts. That's because an ice cube, even though it's so cold, has so much more mass that it has a higher thermal energy, amount of thermal energy. So, very important to understand, even cold objects can have a lot of thermal energy. Think like this. What has more thermal energy? Right now, today is the 30th of December. It's like 18 degrees outside, Fahrenheit. Which has more thermal energy? The thermal energy in your room right now, wherever room you're in, maybe you're in a TV room, maybe you're in a bedroom, maybe you're in a family room, wherever you're watching this laptop, or this video, I'll say this laptop, but this video, which has more thermal energy? The room you're in, or all of outside? Clearly the answer is all of outside. Even though outside's colder, There's so much more mass. You have the entire world outside. You're just in one room, which may be hotter, but there's only so much mass. It's so tiny compared to everything that's outside. So again, all objects, whether they're hot, whether they're cold, have thermal energy. It's just that the more mass you have, the more thermal energy you have. The higher your temperature, the more thermal energy you have. What if we have the following situation? Which has more thermal energy? 100 grams of ice or 100 grams of liquid water? Granted, I guess they would be at different temperatures because ice would be colder than liquid water. So I guess it does make sense that the liquid water will have more thermal energy. But just so you know, going back to this phase stuff, gases have more thermal energy than liquids. Liquids have more thermal energy than solids. Heat. Okay. So here's what heat means. Heat measures the flow of thermal energy from one object to another. I will repeat. Heat is all about the flowing of thermal energy. And it always moves from high temperatures to low temperatures. Just because something is very, 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 very hot does not mean it has very much heat. Again, just because something has a high temperature does not mean it has a lot of heat. Heat is about the transfer of thermal energy. So let's say you have one object that's 500 degrees Fahrenheit. You would agree that's a high temperature. Let's say there's another object that's 499 degrees Fahrenheit. If you put them side by side, there's not that much difference in temperature. So there's not that much transfer of thermal energy. Therefore, there's not that much heat. So again, heat is a relative term. It's like, oh my gosh, I cannot stand when people ask me, is water wet? Oh. So heat and wetness are very similar in that it has to be relative to something else. The term of something's wet, it means, okay, relative to what? So if you put your body in water, yes, now your body became wet. Because before it was dry, it was not absorbing moisture. Then you put it in water, therefore, yes, your body is wet. But it's like that with heat. Heat is a relative term. You can't say something has a lot of heat unless it's two objects that have very, very different temperatures. So again, lots of heat means something can feel very hot or very cold because there's a lot of transfer of thermal energy. What that's saying is it's two different objects with two very different temperatures. So you can have two objects that are very, 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 very cold, and they also don't have a lot of heat. So let's say something is 0 degrees Fahrenheit and 2 degrees Fahrenheit. You put them next to each other. Again, there's not a lot of heat there because their temperatures are so close together. So an example of a lot of heat would be, let's say you have an object that's 500 degrees Fahrenheit and 0 degrees Fahrenheit, and you put them next to each other. That's going to be a big heat. That's a big transfer of thermal energy. And again, it always goes from high temperature to low temperature. So think of this. In the winter, if you ever open the door and your parents yell at you to close the door because you're letting all the cold air in, tell them to shut up, they're ignorant. Don't do that. But they are ignorant because that's not true. You're not letting all the cold air in the house. You're letting all the hot air out of the house. And in the summertime, if they tell you to close the darn door because you're letting all the cold air out, again, they're idiots because you're not letting the cold air out. You're letting the hot air in during the summer. Heat always moves from high temperature to low temperature. Don't call your parents idiots. You're going to get in trouble. It's going to be a bad time. Don't do it. So I kept talking about temperature. What is temperature? So when you take your, let's say you get sick and you put a thermometer in your mouth and you take your temperature. Temperature is the measure of average kinetic energy of the particles. Again, it's the measure of the average kinetic energy of particles. Someone goes, well, if it's kinetic energy, shouldn't it be in joules? Well, we don't do that because it's the average kinetic energy. So we use Fahrenheit, Celsius, and Kelvin. You're very familiar with Fahrenheit. You probably use Celsius a lot in science class. Kelvin, you probably never heard of Kelvin, so don't even worry about it. But just know these are the 3 units for temperature. So the faster the particles move, the faster your average kinetic energy, the higher the temperature. So when you have a fever, it means the particles inside your body are moving faster than they normally do. And the reason why is because they want to raise the temperature to try to kill the bacteria or infection or virus or whatever's making you sick. If particles slow down, then the temperature goes down. So outside in the winter, the average air particles are moving much slower than the air particles in the summer. In the summer, the air particles are moving on average much faster, so there's a higher temperature. But in the winter, those particles are moving slower, so there's a lower temperature. So that's what temperature is. I like it. Hot or cold. So again, it goes back to heat. It's a relative term. I have heard someone complain in class that it's too hot in here. Then literally a minute later, a different student says, no, it's too cold in here. Just because something feels hot to you does not mean it feels hot to someone else. They are relative terms. Here's an experiment you can even do at home that will blow your mind. I'll get to that in a second, but let me say this. Things feel hot if the object you are touching has a higher temperature than you. So again, if something feels hot, it's because that object has a higher temperature than you. This is because you are gaining that object's heat. You're gaining its heat. Things feel cold to you if the object you are touching has a lower temperature than you. And that's because you're losing heat. So when you hold an ice cube in your hand, it feels cold because the ice cube has a lower temperature. You are losing heat because remember, heat always moves from high temperature to low temperature. You're losing heat, therefore it feels cold. But if you put a burning match in your hand, it feels really hot because that hot match is transferring heat into you. It's moving from the match into your hand. So you're gaining its heat. That's why it feels hot. Crazy experiment you can do. Put one finger in really cold ice water and then put your other finger in hot water at the exact same time. Keep both fingers in the hot water and the cold water, one hand in hot, one hand in cold, like this, for about 45 seconds to a minute. Take them both out and at the same time put them both into what I call warm water. It just means room temperature water, just normal room temperature water. It's crazy. So the finger that was in hot water will start to feel colder, and the finger that was in cold water will start to feel hotter, and it feels like in the same cup of water though. So you're gonna have both your hands in one cup of water in the warm water, and each hand's gonna feel different temperatures. It will blow your mind. But again, it just shows you that hot and cold are relative terms. Finally, thermal expansion and contraction. So when objects get a higher temperature, I said this, the particles that make up the object, they move faster because they have more kinetic energy. What happens is because they move faster, they collide with each other more, and it causes the object to expand, to get bigger. Very big misconception. When things get hotter, the particles themselves do not get bigger. I'll repeat that. The particles don't get bigger. The particles hit each other more often. They collide more often, and it causes the object to expand, to get bigger. When objects have a lower temperature, meaning when they get colder, they have less kinetic energy, which means the particles slow down, which means they don't collide as much, and the particles will shrink and contract towards each other. The particles don't get smaller, the object will get smaller because the particles will contract towards each other. So I don't know if you ever drive over a bridge, especially like the Ohio River, the Brent Spence Bridge. You may see this a lot on bridges and such. What these are is that this helps it so like during the summertime and wintertime, in the summertime the bridge will expand. And then in the wintertime the bridge can contract and it won't destroy the asphalt, the concrete. You may see these a lot. So that kind of allows the bridge to expand and contract without breaking the entire bridge. But these are all over the place. But again, thermal expansion. When things get hotter, the particles move faster, causes them to collide more, causes the object to expand. When things get colder, the particles slow down, they don't collide as much, the particles contract closer to each other, and therefore the object shrinks. And there you go. That's everything you need to know about thermal energy in a very short video.